Since every image that you see on a computer, whether it's a still image on the internet, whether it's a video that you're watching on YouTube, whether it's a computer game that you're playing, every single image or series of images needs to be stored on a computer in a particular way. And that's what we're going to look at in this video. So what is it exactly that you need to know for your exam? I'd say you need to know what pixels are, you need to know how images are stored on a computer, you need to know what color depth is, you need to know what resolution is, and you need to know what metadata is. Hopefully those are all answered in this video. The most common type of image that you will see are called bitmap images. They're made up of tiny dots of color, which we call pixels. The color of each pixel is represented by a binary code, so every single little block of color that you see on the screen has got its own binary value. The number of colors available is related to the number of bits that the code has actually got. Might be a useful time to just recap on bits and bytes. 1 bit is the smallest measure of data. So for this particular video, that's going to be really useful to understand. You also have a nibble, and 8 bits is equal to 1 byte. Now a lot of the stuff that we're looking at to do with images and colour is going to be either a few bits or 1 byte or a series of bytes. If you look at the two diagrams at the bottom, one is showing what the computer sees as a series of zeros and ones, and the other is showing what you see as a zero. As a 0 is a white square and a 1 is a black square. As technology started to progress with computers, we could have more available colours. Now if we start off by looking at 4 colour images, we can see that progressing from 1 bit up to 2 bit of colours, we can make 4 colours in an image. So each pixel can be made up of 4 different binary values, either 00, 01, 10 or 11. If you look at the two little examples at the bottom, you can see what the computer would see in binary string and also what you would see with the human eye. So you might notice that 00 is still white, but 10 is a slightly darker shade of grey, and then the 01 is the lighter shade of grey, and 11 is still black. So for example, the black and white image only had 1 bit. Therefore, the total number of colours is equal to 2 to the power of 1, which is 2. So we can either have black or white. A 4-bit image, for example, could be 2 to the power of 4 is equal to 16 colours. The 4 colour image that we looked at before is a 2-bit image, so it will be 2 to the power of 2, which is 4 available colours. When you start getting more bits, you can see there's a massive increase in the amount of colours that are available. So for example, a 24-bit image gives you over 16 million colours. Most modern devices use a 24-bit colour depth. There are 8 bits used to indicate the amount of levels of red, green and blue colours. For example, the darkest red that you can get, as in the most red that you can get, would be 111111, as in full red, and 00000 for all of the green and all of the blue. So the human eye can see about 10 million colours. There's no real need for any higher than that. There's 16 million colours available with 24-bit colour depth. So the word resolution related to computer science is the number of pixels in an image. So the higher the resolution, the more pixels that are in a certain area. The higher the resolution is a better quality image. Resolution is measured in dots per inch. For example, 72 dpi is 72 dots in 1 square inch. From the small diagram here, you can see how many dots would fit in a 1 inch area and how this might improve the quality and clarity of the image. For example, if you get a higher quality image photograph, to use on a larger area, then it will be much better quality if you get 300 dpi compared to 72. You might have noticed measurements used for an image before, or when you set up a new document on Photoshop, where you can say the width and the height in pixels. Well, this is shown here. So 72 multiplied by 4 is 288. So the width of pixels for the image is 288. The height is 72 by 6, so 432 pixels in the image. When you multiply them together, then you can see the full amount of pixels for that image. So in order for the computer to display an image exactly as it's supposed to, it needs a little bit of further information. For example, it will just see a big series of zeros and ones in a big stream, but it needs to understand how many of those bits are going to fit into each particular bit of information. So we use what we call metadata, which is the information stored about an image file. It helps the computer recreate an image using that binary data. So metadata includes the file format, so whether it's a JPEG, a GIF, a bitmap, a TIF file, any of those different formats. It also includes the width and the height of the image, so it knows which pixels are going across, which pixels are going up and down, and so on. It knows the color depth, so for example, if the bit rate changes for color depth from 16 to 24, then that's going to change the amount of ones and zeros to be read at each time. It's going to tell you the overall resolution, so how many dots per inch there are, and it'll also give you a lot of information about the time, so when it was created, when it's last been modified, and finally all of that information is used to create the image as it's supposed to look on your screen. But it's doing this millions and millions and billions of times a second for every single video that you watch, every computer game that you play, every image that you open. Thanks for watching this video. I hope you found it helpful. Please like and subscribe. Bye.